Hi friends, here in this video we'll see the derivation of formula for length of a cross belt drive. And for that, here is the diagram. In the diagram we can see that the bigger pulley is the driving pulley having radius R1. Here is the smaller pulley having radius R2 connected with cross belt, and since it is rotating in clockwise direction, it is going to pull the belt over here, that is this is the tight side, and deliver it onto the other side, which is the tension in slack side. Now this pulley is having radius R1. I'll say this is the driving pulley whose diameter would be D1. Next, here is the driven pulley having diameter D2. Then C indicates the center distance between both the pulleys. Then after that, here there is angle of contact for the bigger pulley denoted as theta, and this theta is more than 180 degree, as we can see here. For the smaller pulley, even over here, the angle theta is more than 180 degree. Now, in order to start the derivation, first I'll write the formula for the length of cross belt drive. Since length of cross belt drive is given by, it is arc CEA plus the length AB plus arc BFD plus length DC. This will give us the complete length for a cross belt drive. Then I'll write this formula in the form of half, that is multiplying by 2 and into the bracket. Instead of writing the complete arc CEA, I'll write only the half, that is EA, plus AB will remain as it is. And for arc BFD, I'll use just this portion B to F. And since I have multiplied by 2, there is no need to write DC. That is what I have done here is taken the length in the form of half, that is arc EA plus AB plus arc BF. Then I have multiplied by 2, which would give us the length of cross belt drive. Now, step by step we are going to move forward, comparing arc EA. When I want this length of arc EA, I should know this complete angle. This angle is 90 degree plus alpha. So length of arc EA, this is 90 degree. I'll write it in the form of radian. So it will be pi by 2 plus alpha. And the radius over here is R1. So this is arc EA. Next, I need to find AB. And this AB is nothing but parallel to O2, which is the center, O2G. So the length of O2G and AB would be same. How to get O2G? Here this angle is alpha. So in this triangle O1G O2, I can say that this O2G is nothing but the adjacent side to alpha, and here is the opposite side. Now, in order to find this O2G, here the hypotenuse is opposite to this 90 degree, which is C. So I'll say cos of alpha, cos of this angle, is equal to the adjacent side upon hypotenuse. Adjacent to alpha is O2G and the hypotenuse is O1 O2. So therefore O2G is what we need here, and it is O1 O2 cos alpha. O1 O2 is the center distance C. So it is C cos alpha, and this O2G is nothing but length of arc AB, because both are same. So here O2G is AB for us. Then I'll put the values arc EA first, pi by 2 plus alpha into R1 plus AB is C cos alpha. Next, similarly I'll get the length of arc BF. So again BF is having angle more than 90. So this is 90 and 90 plus alpha. So that will be pi by 2 plus alpha. and in order to get the length of arc multiplying with the radius r2, that will give me the length of arc BF, pi by 2 plus alpha into R2. Now I'll be simplifying this, that is by multiplying 2 by 2 inside. So this will give me 2 and 2 will get cancelled, pi R1 plus 2 alpha R1 plus 2c cos alpha plus 2 and 2 will get cancelled, so pi R2 plus 2 alpha R2. Then bringing the terms which are similar together. Next, I'll keep 2c cos alpha as it is, and 2 alpha R1 and 2 alpha R2, they would be together. So pi will be taken common, R1 plus R2 plus 2c cos alpha plus 2 alpha common, R1 plus R2. So this is the exact length of cross belt drive, the formula. So I'll keep it as equation A, and I'll mention here that therefore equation A gives the exact length of a cross belt drive. Now, in order to get the approximate length, I'll have to replace here cos alpha and alpha with some values, because I would be bringing this formula into the form of just 3 values, that is R1, R2 and C, replacing alpha and cos alpha, because this formula gives the exact length. Now to get the approximate length, I'll say that while looking into this diagram, I can say sine alpha, sine of this angle, is opposite side, which is O1G, to the hypotenuse, which is O1O2. So O1G is this complete radius. So this is radius R1 from O1 up to A for the bigger pulley, and A to G is nothing but the radius of the smaller pulley which has been projected parallelly. So this is R2. So O1G is R1 plus R2 divided by O1O2, which is C. So this is the value of sine alpha. Now I'll say, since sine alpha is equal to R1 plus R2 by C, and therefore as the alpha value is very small, so we can say that sine alpha value is approximately equal to alpha, as the value is very small. So alpha will be R1 plus R2 by C, keeping this as the first equation. Then I even want the value of cos alpha here. So for that I can say that since cos square alpha plus sine square alpha is equal to 1, so therefore cos alpha will be 1 minus sine square alpha, and here I'll be taking the root, and this same thing can be written in this way, that it will be 1 minus sine square alpha raised to the power half, since it is root. Next, after reaching up till this stage, as we know this sine square alpha, sine alpha is same as alpha, so here I'll be getting 1 minus alpha square raised to the power half. Then by using binomial expansion, cos alpha would be equal to 1 minus this half would be multiplied half into alpha square. Then I'll put the value of alpha, which is R1 plus R2 by C. So cos alpha will become, this is the value of alpha. Now in the next step I would be putting the value of both alpha and cos alpha in equation A. Cos alpha, for that I am keeping this as equation second, and alpha we have got it in equation number 1. So I'll write down, put alpha and cos alpha in equation A, which was giving us the exact length of the cross belt drive. I'll put the values here. So therefore we are left with pi r1 plus r2 plus it is 2c cos alpha. So I'll put the value of cos alpha, 2c remaining as it is, 2c cos alpha is this value, 1 minus half of r1 plus r2 divided by c whole square plus 2 into alpha, and alpha value is there in equation 1, which is r1 plus r2 by c, and into r1 plus r2, that is in equation A. Now simplifying this, pi r1 plus r2 will remain as it is, then plus 2c, next minus, here we are having c square, so this will be 2c square, and when I multiply with 2c, 2 and 2 gets cancelled, 1c will get cancelled, so in the denominator it will be r1 plus r2 divided by c, and here we have plus 2, and this is having c square, this entire term is having square and c is out of that, then here we have plus 2 into r1 plus r2 whole square divided by c. So finally this will be pi into r1 plus r2 plus 2c will remain as it is. Now these are the same terms. This is plus 2 minus coefficient is 1, so that will give me plus 1. So plus of r1 plus r2 whole square by c. So I'll say this is equation B, and when I compare equation A with B, equation A was giving the exact length of belt drive in the form of alpha and cos alpha, and equation B, that alpha and cos alpha term has been replaced with C and R1 R2. So I will say that equation B gives the approximate length for a cross belt drive, and when we compare it with the length of an open belt drive, only over the last term here we have minus, the entire formula remains same, and with this the derivation of the length of cross belt drive gets completed.